Hey guys, Remy here, how's it going? In today's video, I'm going to be showing you how to interact with Ethereum by using a wallet. You're going to be installing an Ethereum wallet onto your machine, and we're going to be using that wallet to make transactions in order to send and receive funds in Ether. And then in the end, we're going to be building and deploying a simple smart contract onto the Ethereum network and interacting with it. Before we get started, let me briefly touch on the concept of a wallet. What is a wallet? Any wallet must have at least two basic functions. One is to be able to interact with the main network in order to broadcast the transactions, and two, to be able to store the private keys. So what is a private key? When you make an account on the main network, you're assigned an address, and that address may contain some amount of Ether as funds. In order to be able to transfer that Ether from your address to another address, you need to be able to prove before you can initiate a valid transaction that that address belongs to you. And the way you prove it is by using your private key. There are different types of wallets out there. There are software-based wallets which run directly on your computer or on your mobile phone and store the private keys locally. There are web-based wallets which store the private keys on the web browser, and there are hardware-based wallets which are basically like an encrypted hard drive that store the private keys on the hard drive, encrypted and disconnected from any other external system, meaning that you actually have to physically connect to it in order to be able to extract the private keys. For today's video, we're going to be using one of the most popular wallets out there called Metamask. Metamask is a web-based wallet. In order to get Metamask, navigate to the Chrome Web Store from where you can download and install extensions, and type into the search box the word Metamask. And once you search for it, make sure it is offered by metamask.io, just to make sure you're installing the legitimate version of it. And once you click on it, it should have more than 4 million users and more than 1900 reviews. So once you are sure that it is the legitimate version of MetaMask, go ahead and install it. I've already installed it for myself, so I'll let you do that now. As you make your account, you'll be prompted to create a password. Make sure that password is strong, because that password is going to be used to encrypt your private key. Since your private key is stored locally on your computer, in this case in your web browser, anyone with access to your computer can just go to the folder where it's stored and they can just get your private keys. However, unless they also know the password, they won't be able to decrypt those private keys, and hence they're going to be useless to them and they won't be able to access your account. On the other hand, if somebody gets a hang of your password from somewhere else and has no access to your computer, that password is also going to be useless to them because they have no private keys. So make sure that password is strong and don't forget it, because you won't be able to use your private keys unless you also know the password. Another thing you're going to be prompted with is a 12-word phrase of random English words. Now, before you do anything else at all, write those words down on a piece of paper, put them on your desk, and now I'm going to tell you what they mean. Basically, if you lose access to your computer for any reason, you'll also lose your private keys, right? So suppose you store your private keys on your hardware wallet. It's a hard drive. You can lose your hard drive. You can get damaged. You can lose your computer. You can explode. You'll lose your private keys. So that phrase can be used to generate your private key anew, which means that if you lose your private keys, as I've mentioned so many times before, you'll be able to regain access to your account by regenerating your private key from that phrase. That also means that anyone else in the world who has access to that phrase, who has the possession of that 12-word random English words phrase, is going to be able to also generate your private key and hence steal all of your funds. And that's not fun. So make sure you store it in a secure place such that you can always get to it, but nobody else can. Now let's get back to it. So once you have MetaMask installed, this is what it more or less looks like. You can send funds, you can receive funds. So this is your address right here. This is the address of your account. If you wanted to provide this address to someone in order for someone to be able to send you funds, you will use this address. Now, at the moment, as you can see from this drop-down box, we are connected to the Ethereum mainnet, which means that anything we do here, sending funds, receiving funds, is going to be done on the Ethereum main network itself. Every transaction in the Ethereum main network incurs a gas fee. Of course, we want to be able to learn for free, so we're not going to be using the Ethereum main network for our learning activities such as deploying our smart contract and sending transactions. Besides, we have 0 Ether, so we can't go on really. So we're going to be using a test network. Test network, such as the Ropsten test network, which is the second one on the list, is basically just an emulation of the Ethereum main network, but with free Ether. So we can test anything we'd like, and if it runs well on the Ropsten test network, you can be sure that it's going to run just as well on the main network. So first order of the day, let's get some Ether. I already have 1.89 test Ether, which has no value, but you'll probably have 0 at this moment since you've just installed Metamask. So in order to get some more Ether, click buy, and then go ahead and get Ether from a faucet for the Ropsten. So just click get Ether, and you'll be able to get it from a faucet. So you'll go to this little web page here and just say request 1 Ether. So this is the faucet. It has the balance of this much Ether in there. Go ahead and request 1 Ether. And now that that's done, the transaction's been requested. Now we're gonna wait a few seconds, up to maybe a minute. I don't think it's gonna be a minute, but it's gonna be a little while before the transaction is actually gonna be put into a block and mined by the miners of the test network. But once the transaction is processed, we're gonna see that our balance on MetaMask will have increased. Also, it is going to notify us when the transaction is actually done with a little pop-up window JavaScript alert. It's gonna wait a little while, and in the meantime, oh, there we go. See, the transaction's been completed, and I've now received 1 whole Ether. So what you've now done is you've interacted with the Ethereum, with the test network. I'm just gonna call it the Ethereum network for all practical purposes because it's almost exactly the same thing, but free. So you've just interacted with the Ethereum network and you've received 1 Ether from it. Now let's go ahead and send half of your amount back to where you got it from. So you got it from this address right here. So basically go ahead and copy this address, and let's send half of our Ether back to this address and see how that works. Trying to copy and paste this. Yeah, there we go. It was unhighlighting it. So let's go ahead and send Ether. So we'll put in the address right here, and we're gonna send let's send 0.5 Ether, 0.5 back to the to the faucet. Obviously, when we send Ether or when we send Ether, it incurs a transaction fee called the gas fee. So this is gonna be the gas price, 1.05, denominated in Gwei, which are gigawatts, which is the denomination of Ether. And the gas limit is going to be 21,000 Gwei, which means that it can never go over 21,000 gigawatts, which is, like I said, a denomination of Ether. And I'll show you a table in a little bit. But in the meantime, let's press next and press confirm. And now the transaction's been initiated. We're just going to have to wait while this transaction is added to a block and mined by the miners of the test network. And once it is mined, which means that the block is verified, we will lose 0.5 of our Ether, and it's going to be sent back to the faucet. All right, there we go. The transaction is now confirmed, and we've now subtracted 0.5 Ether from our balance, and it's been sent back to the faucet. All right, now that we've interacted with the Ethereum network and made some transactions, let's up our game a little bit and make a smart contract and deploy it onto the Ethereum network. We're gonna make a simple smart contract called the faucet, which is gonna be exactly the same as the faucet we used to fund our test account. So what is a faucet? A faucet is basically an account running on the Ethereum main network that has a balance, and it does one of two things. It accepts Ether from anyone who sends it Ether, and it sends Ether to anyone who requests Ether from it. So let's go ahead and see what it would look like and actually make one. In order to make a smart contract, you'll have to use some Solidity, the programming language that runs natively on Ethereum. There are many ways to do this. You could download your own compiler and do it on your own machine, but for the purposes of this video, we're going to be using an IDE called Remix. So go ahead and go to the URL remix.ethereum.org. It should look something like this. And then Once you are on this page, on the contracts folder, click new file and call your new smart contract offset.flow. So basically, this is an IDE that allows you to code in and compile Solidity-based smart contracts and deploy them directly onto the Ethereum network. So there's a lot that comes in the box itself. Let's just zoom this in quite a bit so we can see really well, because initially the default settings are meant for ants on this page, but luckily we can zoom in. So let's first go to another smart contract. So there are a few examples. So we can go here. Actually, it's too zoomed in. Let's zoom it out a little bit. Like this. Okay. So let's go ahead and copy and paste the overhead, which is just the comments. And so basically, these are the comments specifying the license type that the Solidity contract uses. The license type of Solidity itself, and then this line here specifies the version of the compiler that's going to be compiling your Solidity code. And this here is just the description of your contract. So let's call it set, and let's just give it a short description. Say implements a practice set. Okay, that should be good enough. So let's get to it and let's program the actual contract. So in order to program the actual contract, we need to define the contract as follows. So we'll say contract, and we'll call it for set, and we open curly braces. Now, close curly braces. Now, almost immediately, as you might have noticed, this contract definition is basically like a class definition of many other programming languages. So in Solidity, we call it a contract, but it's basically a class. It's easy to think of it that way. So within this contract, you can have functions. So what does the faucet do? As we've discussed before, the faucet either accepts ether from anyone who sends it ether, and it sends ether back out to anyone who requests ether from it. So those are two separate functions. So let's define the first function to accept ether from anyone that sends it ether. This one is going to be really easy. So basically, the function is called receive, with the little parenthesis that takes no parameters, and it's going to be external payable, which is just a bunch of keywords, and it's going to take no argument. So there's going to be nothing in the function, just this. So basically the function is called receive, and the function is external and payable. So those are the keywords that basically define this particular function, meaning that anyone who sends ether to this contract, the contract will be able to accept this ether and store it as its balance. Now, our next function is going to be a little bit more fun to define. This function will take the address of the account that has initiated this transaction, and it's going to send them back a certain amount of ether. So let's define this function. We'll say function, and let's call this function withdraw. So we'll say withdraw, open brackets. And in this, we're gonna have a variable called unsigned int defined by uint. And let's say this function, this variable is gonna be called withdraw amount, which is gonna be the amount of ether that's gonna be sent back to the person who initiated this transaction. Open brackets, close brackets. Now, inside of this function, what we are going to do is we are going to basically transfer the withdraw amount to the address. So in order to do that, we say message dot sender dot transfer, and we are transferring the withdraw amount. And Solidity uses semicolons to finalize statements. Now let's dissect this line a little bit. Message is something is an argument or a variable that every smart contract has access to. Basically, in order to interact with a smart contract, you have to initiate a transaction. So every smart contract will have message. This is the information about the address who has initiated the transaction in order to be able to interact with the smart contract. Now, .sender, so message contains a variable called sender, and this variable is basically the address of the account who has initiated this transaction and interacted with the smart contract. So we're going to be transferring to this address the withdraw amount. Now, in order to do that, what we're going to do is we're going to first check that we don't want anyone to just withdraw our entire balance, right? We want to give little bit by little bit. So we're gonna make sure that the amount that they withdraw is not more than 0.1 ether. So that's the max we can send out at a time. So we'll say we'll just basically say requires, and it's require, and we'll require that the withdraw amount will be less than or equal to, and it's going to be less than or equal to 1 followed by 17 zeros. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So this 17 zeros defines one way, which is the smallest denomination of ether, and it is how all of the balances in the Ethereum network are actually denominated. They're denominated in way. So here's the table that I was promising to show you. So these are the different denominations of ether. So ether itself that we are familiar with is right here, and the smallest denomination of ether is called way, which is exactly what we've just used here. So 1 followed by 17 zeros ways is equal to 0.1 ether. So 1 way, and then we have 1 kiloway, which is 1,000 ways. Then we got megaway. We got gigaway with gas fees are denominated in gigaways normally, and then we got micro ether, milli ether. Then we got the actual ether. Then we got kilo ether and mega ether. So everything's denominated in ways, which is the smallest denomination, and this right here is equal to 0.1 Ethereum. So in order for this address to actually be able to in order for us to actually be able to send funds to this address, we need to make it payable. In order to do that, all we have to do is cast it as a payable object. So we'll say payable, and then we'll cast message to sender as a payable object. And this is basically it. So this is our smart contract. So let's recap of what we've actually done here. What we've done here is so we can receive money. So this is our first function. We can receive money. We can receive ether into this smart contract, and we can withdraw ether. So anyone can initiate a transaction that calls this withdraw function with the withdraw amount as the parameter. We'll first require that withdraw amount be less than 0.1 ether, and then afterwards we'll be able to send to the sender of this transaction. We'll be able to transfer to them this amount of ether. So let's go ahead and compile this contract. In order to compile, we just click on this tab right here, and we'll use the right compiler. That's all done. So just default values. We'll say compile faucet.sol, and there's an error, of course, because I forgot the semicolon right here on line 16. So now that we have the semicolon, let's try this again. Now line 14 is complaining because the function should be public. Of course, the function is either private or public. Yes, and the message actually says right here, did you intend to add public? Yes, indeed I did. This means that anyone in the world can interact with this function of the contract. So let's try to compile it again. Now we have no more complaints from the compiler, and our contract is compiled. So now that it's compiled, let's actually deploy it onto the test network in Ropstein and see how it works and how we can interact with it. So click this tab that says deploy, and in your environment, click injected web3. That means that you'll be able to do it with Metamask. So with injected web3, you have this address right here. This is your Metamask address, same as this one. So we're using Metamask as the endpoint in order to be able to interact with the Ethereum network to be able to deploy this smart contract. Then of course we'll specify the gas limit because every interaction with the network has a gas fee, and we deploy this contract and just click deploy. Then Metamask will ask for a confirmation, and you just go ahead and confirm. And the transaction has been initiated. Now, all we need to do now is to wait for this transaction to be added to a block and be mined. And once the transaction is mined, we'll be able to interact with the smart contract directly on the test network, or the Ethereum network. All right, so now that's done. We can see that the transaction is confirmed. We can view it on Etherscan. So if you click this link right here, it's gonna take you to the website called Etherscan, and you'll be able to see on this website. By the way, this is Etherscan for our test network, not for the main Ethereum network. And once the block is verified, we'll be able to see the actual contract in action. All right, so now that our smart contract is deployed on the Ethereum network, and we can see this on Etherscan, the contract at this address. This is the address of our smart contract. It has 0 Ether as its balance. So firstly, let's transfer some Ether to the smart contract. So let's go ahead and copy this address. And in our Metamask, we're going to send to this address, to this contract that we just created, we're going to send 1 Ether. Let's go ahead and send 1 Ether to it. Just go next, confirm the gas fee, that's all good. Next. And we have initiated the transaction. As soon as the transaction is confirmed, we are going to have a balance of 1 Ether on our smart contract. All right, so now that our transaction is confirmed, let's refresh this page. And we can see that our smart contract actually has 1 Ether as a balance. So what we've just done is we've transferred 1 Ether to the smart contract, meaning that we've invoked this function right here called receive in order to transfer this Ether. Now let's withdraw some Ether. So remember, we can only withdraw 0.1 Ether at a time, so that's what we're gonna do. So let's Control C this number, copy this number, and to interact with the smart contract, we can use Remix for that. And in order to do that, we'll just use the same tab as we've deployed it, and down here we can see that we have this smart contract as deployed contracts, and within it we have the function called withdraw. So let's copy and paste this number right here. And one thing about these smart contracts and how we interact with the Ethereum main network or any test network is that the interaction actually happens through something called web3.js, which is built in JavaScript. And JavaScript has a little limitation to it where, for example, this number right here, 1 followed by 17 zeros, is way too big for JavaScript to process as an int, and it's just gonna reject this call and throw an error. So in order to work around this, we're gonna pass this number as a string, and our contract is gonna be smart enough in order to tell that this number should actually be an int, and it's still gonna process the transaction. So put the braces. So put the braces around brackets around this number to pass it as a string, and click withdraw. Let's see if it obviously the MetaMask wants us to confirm because we have to send the gas fee. So the gas fee in this case is gonna be 1.05 gigaways with the limit of 30,000. And let's confirm this transaction. And let us wait for this transaction to be complete. But once the transaction is confirmed and the block is mined, we can see that it worked because the balance of our smart contract is now 0.9 Ether. And in MetaMask, we can see that our balance has increased by 0.1 Ether. So what we've just done right now is we've basically we've called that withdraw function that we've called it into our smart contract, and we've successfully interacted with the Ethereum network in order to deploy a smart contract and then send it some money so that it has a balance, and then interact with the functions that we've implemented into the smart contracts to get the money back. Ethereum and blockchains in general is a marvelous new technology, and we're still in the early days. In today's video, we've learned how to interact with Ethereum using a wallet, how to build and deploy and interact with smart contracts. In the future videos, we'll discuss these concepts in more depth, as well as learn how to make smart contracts that are more interesting, more complicated, and more useful and applicable to real-world situations. So in order to not miss those videos, please subscribe to my channel, give a like to this video, and as always, I will see you in the next one.